Hi, my name is Magnus Fredriksson and I am from Luleå University of Technology in Sweden. I've done this study together with Mikael Svensson of the company LSAB, also in Sweden. That's me on the left and him on the right. So the background for this study is in the sawmill process, you turn logs into sawn timber or boards. And you want to retain as much volume as possible from these logs, usually expressed as volume yield. And to maximize this, you can, for instance, sort logs into different size classes and process them in different ways depending on the size. You could also have more sophisticated optimization softwares based on scanning of the logs, for instance, in the saw line. And of course there are other processes affecting the volume yield also, such as drying. But where we want to focus is the sawing process and more specifically what happens here when the saw blade removes material from the log. Because this is a material loss, of course, and what you want to do is to reduce this as much as possible, keeping the saw blades as thin as possible, while retaining a stable sawing process. And in this development, it is of interest to be able to quantify how much volume yield you can gain by reducing this saw blade thickness. So that was basically the aim of this study. And what we did was to develop 12 different scenarios. I don't have time now to go through all of them, but we will focus on one of these branches in the tree where we have optimized sawing patterns depending on the shape of the log. We have studied a bandsaw with 4 different kerf widths: 2.9 millimeters, 2.0 millimeters, 1.5 and 0.8. And the material that we used was the Swedish stem banks, where we have trees from the forest that has been bucked into logs. They have been CT scanned. Image analysis was performed, thus creating log models that can be used for sawing simulation. We used 714 Scots pine logs and 756 Norway spruce logs. And the sawing simulation software that we used, we can import these log models and saw them into boards and get information on each of the boards. We can do edging operations that are value optimized, and we can also do trimming. If we have a defect at the end, for instance, it can be cut away if this means that the overall value is improved. We can also look at different sawing patterns, different tools, different qualities of the boards, which can then be assigned a value, of course. But what we wanted to focus on in this study was the tools, the kerf width, and the volume yield. So for the results, when sawing these logs, first by 2.9 millimeter kerf width, then by 2.0, then by 1.5, and then by 0.8 in this scenario. And when doing so, we can see that there is quite a linear relationship between the volume yield and the kerf width. So for each millimeter of kerf that we can reduce, we can gain about 1.4 percent units of volume yield. This is the main conclusion also from the study. When we looked at all the other scenarios, we saw that the level was somewhere around here, just below 1.5 percent units. So, thank you.